This video will work a sample problem where a person is trying to descend in a controlled way down to the ground from a ledge that overhangs Swanson Hall. Swanson Hall is a science building where I taught my last job. I retired in 2015. But we have, I'll call him Bob, descending here. We did not do this in practice. None of my physics students were allowed to try this out in practice, but he's descending from the Swanson Hall. It's a thin rope. It can only support 600 newtons of tension before it breaks. I'm giving Bob a weight of 90 kilograms. We'll soon discover that 90 kilograms creates a weight greater than 600 newtons. So how we're going to get Bob down? We're going to let Bob accelerate at a constant rate towards the ground such that we don't exceed the tension in the rope. The upward force, I'm going to use positive as the up direction, and we have 600 newtons available upward from the tension in the rope. The weight of Bob is mg, mass times acceleration due to gravity, and that's a negative number. It's in the down direction, so minus 882.9 newtons, and we find that Bob's weight is greater than 600 newtons. So if Bob just is stationary, the rope will break. So we're going to let Bob accelerate. We're going to make Bob accelerate such that we only demand 600 newtons of tension in the rope. So the forces are not balanced. We have 600 newtons available from the rope upward, and we have a weight downward on Bob. These are the two forces that act on Bob. 600 newtons from the rope acting upward on Bob, force of gravity downward acting on Bob. We're going to cause an acceleration and use Newton's second law to find what that acceleration is. So Newton's second law, the net force is equal to the mass times the acceleration. The net force, we can easily combine the two numbers, 600 upward minus 882.9 downward, so we get this calculation for net force. We were given Bob's mass is 90 kilograms, so we can calculate the acceleration Bob has to have. Again, pause this and pull out your calculator and see if we're in agreement here. I came up with an acceleration rounded off to minus 3.14 meters per second squared, negative because the acceleration is down towards the ground, and I chose up to be the positive direction. So there's our result. What is reasonable about this? Well, it's smaller than 9.81. The rope is helping us have a controlled descent down to the ground. We're not accelerating down at 9.81 meters per second squared and falling too fast. We're at a number that's smaller than 9.81 meters per second squared. So in that sense, it's a reasonable result. Well, if you'd like to see some other worked out sample problems and some short lectures, I've organized a list of my YouTube videos at my website, gpclements.com. It's organized by topic. There's a title of the video, how long the video is in minutes, a description of the video, and there's a direct link to YouTube. So you can click on that link and watch the YouTube video. All the content's free. I don't allow people to resell it. It's all free and will remain that way. You don't give me your name or register or your email address, any information, and my website does not put cookies on your computer. So keep working sample physics problems and ask your instructor when you have questions.